v- a very good afternoon to you guys. Dinesh here. This is my first YouTube channel which I'm publishing on YouTube. It was regarding important question which has been asked from ninth. A lot of the time when this question is being asked. So the question which I need to discuss is about the 12th science physics paper. I'm discussing about your Maharashtra board, which they have the paper on this 26th of them. Right. So important question which I'm going to discuss about circular motion, gravitation, which is I'm having a conversation with you with regarding to this chapter is like this question are asked majorly. I mean this question are asked like 2011, 12, 13, 14. The majorly this question has been asked. So today we are going to discuss such a question, sir. So let me come to the first chapter, guys, which is nothing but your circular motion. In the circular motion, a very important question I can say. Let's discuss about the question like a 2 marks, 3 marks question. Then when I'm going to come down to be a numericals part, then I'm going to talk you about the filling the blanks, which is asked about it. So the first chapter for the physics paper 1 for the Maharashtra board. Here is your first chapter. That's your circular motion, guys. The first question which is very important we ask is your what do you mean by the relationship between your linear velocity and angular velocity? That's the first question, which is already almost every time this question has been asked, which is asked for the 2 marks. A relation between your linear velocity and angular velocity. Here I need to prove the formula V is equal to R omega. Second question, guys, I can say that question which has been asked is like if the body is doing a non-UCM, right? If the body is performing non-UCM, non-uniform circular motion, what does the linear acceleration body have? That's a question which has been asked. Otherwise, the frame of the question might be define centripetal acceleration and get the expression for the acceleration of a particle performing UCM, right? So this might be the performing non-UCM. This might be the way they frame out the question. So if the body is performing non-UCM, I need to find out uska linear acceleration. The derivation that I need to perform is A is equal to under root of A R ka square plus AT ka square. Again, this derivation is asked for the March 14, May 15, and again, guys, they have asked you the 17 paper. So please do it very importantly, this question. Second, they ask the question is like expression for the banking of road. Banking of the road expression they ask almost times they already ask for the 2 marks like that's banking of road diagram just for the 2 marks say, which is very simple. So please refer that diagram as well as the derivation. Derivation is very simple, guys. If you observe it, that's a I can say rectangle, I can say floor on which the car need to be ridden out, right? So the right hand side, which is nothing but your centripetal force, is balanced by your n sin theta. Here I will get a equation number 1. Second, I need to have a look that this one n cos theta is balanced by your this one mg. So I need to balance such a force, and I will getting divide 2 by 1. I'm getting a tan theta is equal to v square by gr. So please do that question again. It's a very important question. Okay, coming down to be, guys, a conical pendulum, a time period equation. I need to find out what's the time taken by your pendulum to complete your 1 revolution. This question is also considered as an importance. The numerical has been asked on this question. So please do this question as well. The formula is T is equal to 2 pi under root of L cos theta divided by G. Again, guys, derivation, don't do the derivation which I'm going to tell you. Expression for the tension in the VC motion. If the body is performing vertical circular motion, what's the expression? Right? There are different tension expressions. That what's the tension expression, height, middle, and the bottom. So I need to doesn't have to do the derivation for the board exam. I just need to understand the formula. Tension at the board, I can say top position is like mv square by r minus mg. At the middle position it's mv square by r. At the bottom position is mv square by r plus mg. Of course, this tension at the bottom side is larger. So please do this question also. This is also a very important base on the concept of your numericals. So please do this question. The question again, guys, velocity ke upar also they ask you. I should know the velocity ke formulas. Again they ask it. So for the filling the blanks, guys, for the filling the blanks, they ask the question like which is almost came 2-3 times. The difference between tension at the lowest and difference between tension at the highest is equal to what? Your 6, 5, 4. Answer is 6 mg. That's the filling the blanks. They all every time is asked it. Okay. Coming down to the numerical parts, guys. Numerical part I need to sort it. What's the angular velocity? That type of the sum I need to sort it out. Again, banking or fraud का formula, which is a very important, right? I need to know the formula of banking and unbanking. They majorly ask you the banking wala formula and the question on base, right? I've been given everything, like radius has been given, theta has been given. I need to calculate what the velocity I can travel safely. So please do that type of a sum also. And guys, tension ke sum, of course, they ask for the numerical side as well as the velocity ka. So this is my first video. Have a look and check it out, the circular motion. All the best. I'm going to also to prepare a video for, I can say, combination one video which will be including all your physics. So let's see how the things goes on. I will going to put it on as soon as possible. Bye.